Hello and welcome back to the AeroFLYhub podcast, where we explore the fascinating world of aerodynamics. I'm your host, and today's episode is all about the principles of flight. We'll be discussing Bernoulli's principle, Newton's third law of motion, angle of attack, and airfoil design. Let's start with Bernoulli's principle. Daniel Bernoulli, an 18th-century Swiss mathematician, discovered that as the speed of a fluid increases, its pressure decreases. This principle is fundamental in understanding how lift is generated. On an aircraft wing, the air moves faster over the curved top surface and slower underneath. The difference in speed creates a pressure difference, producing lift. Next, let's discuss Newton's third law of motion. For every action, there is an equal and opposite reaction. This law explains how thrust works. When an aircraft's engines push air backwards, the reaction is a forward push, propelling the aircraft. Now, let's talk about the angle of attack. The angle of attack is the angle between the chord line of the wing and the oncoming airflow. A higher angle of attack increases lift up to a point. However, if the angle becomes too steep, the airflow can no longer smoothly follow the wing's surface, leading to a stall where lift suddenly decreases. Airfoil design is another crucial aspect. An airfoil is the shape of the wing as seen in cross-section. The design of the airfoil affects how air flows over the wing and thus how much lift is generated. Different airfoil shapes are used depending on the type of aircraft and its intended flight characteristics. Now that we've covered these principles, let's see how they work together in practice. When an aircraft takes off, the pilot increases the angle of attack to generate more lift. The engines produce thrust to overcome drag and accelerate the aircraft down the runway. As the speed increases, lift builds up until it exceeds the weight of the aircraft, allowing it to take off. Once airborne, the pilot adjusts the angle of attack and engine power to maintain level flight. In turns, the pilot uses the ailerons to roll the aircraft, changing the direction of lift and causing the aircraft to bank. The rudder and elevators are used to control yaw and pitch, ensuring smooth and coordinated turns. These principles are not only vital for aircraft but also for other flying objects like helicopters, gliders, and even drones. Understanding them is key to designing efficient and safe flying machines. In our next episode, we'll dive deeper into the forces acting on an aircraft, including lift, drag, thrust, and weight. We'll explore how these forces interact and how pilots control them to achieve stable flight. Thank you for joining me on this episode of the AeroFLYhub podcast. I hope you enjoyed our discussion on the principles of flight. Don't forget to subscribe and leave a review if you liked the episode. Until next time, keep your curiosity soaring high. Signing off.